In this video, I'm going to show you how aldehydes and ketones react with primary amines. Now stick around to the end of the video because I'm going to show you, one, how organic chemistry professors try to trick you with one question you might find on the exam. And two, I want to show you one way you can use this reaction in the lab as a test for unknowns. Let's jump right in. A primary amine is one where we have a nitrogen compound with one carbon group attached, one R group attached. This is what makes it a primary amine. And if I take that primary amine and I react it with a carbonyl compound like an aldehyde, we undergo what's called a condensation reaction. That means you make water. Condensation reaction. And if I lose a water molecule, now I have my carbon with a hydrogen. This is an aldehyde with an R. I lose the water, so on this double bond, now I have this nitrogen, and my methyl is still there, CH3. So primary amines react with aldehydes or ketones, if this was a carbon, to make what are called imines. An imine is a carbon double bond nitrogen, or some people call that a Schiff base. But ketones and aldehydes react with primary amines to make imines. Here's a ketone, two carbons on a carbonyl, and let's react that with phenylamine. I can lose water to make ethyl on my carbon, double bond to a nitrogen, and my phenyl is on there. Pretty easy reaction. So here's one of the questions they'll ask on an exam, which is sometimes a little tricky at first. They'll take a compound like this. And they'll say, how does this react? And some students, they get a little confused and they'll think, well, let's see, if I have a whole bunch of these in my beaker, maybe what the professor wants is this molecule will swim around until it bumps into another molecule of itself. It'll lose its water, and they'll draw something like this. Nitrogen to this carbon. And they'll draw some big molecule like that. But what I want you to think about is, if I were to ask you, hey, you're at a party, everybody's blindfolded, and the game is you need a right hand to find a left hand and hold a left hand. So right hands find left hands. Is it easier for all of the people walking around blindfolded to reach out their hands and to find a left hand to shake hands with? Or is it easier for all the blindfolded people just to go, well, wait a minute, I can just do this. And they reach around and grab their own hand. Of course, that's easier. And that's what happens in molecules like this, where the two reactive groups are inside of the same molecule. This NH2 can reach around, the right hand can grab this left hand, this oxygen, and react. So let's see what that would make. Let me redraw that. So here's my carbonyl, my hydrogen, and I'm going to label and count how many of these I have. I have 1, 2, 3, 4, 5 carbon atoms. So 1, 2, 3, 4, 5, and then my nitrogen is attached. So when I lose my water, I'll make a molecule that has 1, 2, 3, 4, 5 carbons, and nitrogen makes number 6. So I'll make a ring with a nitrogen in it and a double bond. There's my imine. So that's the little trick that they'll ask on an organic chemistry exam. There's one more of these I want to show you because it's important in the laboratory. It's the exact same reaction, so it's not too hard to do. But this molecule with two nitrogens, two NH2s, is called hydrazine. And hydrazine could react with a ketone or an aldehyde. It doesn't matter if it's a hydrogen or a carbon here. I can do a condensation reaction, lose my water again. And I can make, in this case with my aldehyde, hydrogen, carbon, R group, double bond to my nitrogen. So now this nitrogen lost its water. So now I just have this NH2 on it. And I make what's called a hydrazone. In the lab, 2,4-DNP or 2,4-dinitrophenylhydrazine, huge long word, sometimes called Brady's reagent. 2,4-DNP is this. So it's 2,4-dinitrophenyl. So on my phenyl ring, my benzene ring, on the second, 1, 2, and the fourth, 1, 2, 3, 4, I have my two nitro groups. So 2,4-dinitro on the phenyl. And this 2-nitrogen thing we said was hydrazine. So 2,4-dinitrophenylhydrazine. But just know that 2,4-DNP is this big group on a hydrazine. This is a chemical, Brady's reagent, that I can use in the organic chemistry lab whenever I have an unknown compound that I think might be an aldehyde or ketone. There's some evidence for that. Maybe in the infrared spectrum, I see a big peak at 1700, and I'm thinking, I think I might have a carbonyl. Well, I can take my aldehyde or ketone, which might be a clear, colorless liquid. Let's pick a ketone like acetone. So I can have this colorless liquid. I can take this orange solution called 2,4-DNP, this orange liquid, mix them together, and if I have a carbonyl, I'll lose my water, and I would make CH3, CH3. I lost my water, so I have a double bond to this nitrogen. Whoop, there's no hydrogen there. To this nitrogen. So basically I made a hydrazone with this big heavy group on it. That big heavy group helps us become a solid. So these two liquids, all of a sudden I get a red or orange solid which precipitates out of solution that I can filter and use. But I can see these two liquids, if they make this orange solid, aha, this liquid must have had a ketone or an aldehyde in it. That's a chemical test for if you have a ketone or an aldehyde. Pretty easy. Hey, I hope that was helpful. Look and maybe click on one of the links to my other videos on carbonyl compounds like ketones and aldehydes doing reactions. Or subscribe to the channel and watch more of these videos so I can help you be successful in organic chemistry.